This is Max Gravett with Digital Scarcity. The purpose of this video is to provide a quick explainer and a demo of how I'm using EOSIO and IPFS to communicate private financial transactions on a public blockchain. So for the use case, generally speaking, this is for foreign direct investment into the United States and involves a number of parties. The builders, large builders in the US, seek capital for their projects, and mostly these are hospitals, apartment complexes, shopping malls, and the foreign nationals seek a return on capital and also to use the EB-5 immigration program. So this program provides immigration benefits to foreign nationals that invest in eligible projects in the United States. There are, there's certain criteria that make investments eligible. Job creation numbers, minimum investment size, I imagine. And then this criteria is set by the federal government, and it also is audited. And the financial services organization it manages all the coordination, regulatory compliance, setting up corresponding corporations, managing the accounting, legal agreements, and essentially is the liaison pulling all this together from these various parties. And the end market investment hubs really cater to the individual investors, facilitate the flow of capital, give status updates back to the investor, the return of capital, of course, and then a coordination of the immigration benefits. So why blockchain? So I imagine foreign direct investment comes with risks, crossing borders, even in the United States. It involves unfamiliar locations, brands, companies, etc. And they desire transparency. The investors desire transparency. They want to know, the status of their capital, what it's being used for, the status of the projects, just like any investor would. It just gets a bit magnified because it is, crossing borders. And in general, the more transparency that we can provide to the investors, it'll should create more investors and greater access to capital. These projects do have a ton of paperwork. Like I said, legal agreements, proof of purchase orders, evidence of project status, audit trails, and it goes on and on. And so the blockchain will keep all these materials, at least all the important materials, in one place where it's immutable and easily accessible. And for the auditors, who we certainly want to make their jobs easy. So it's on a public blockchain for this example. It's not limited to a public blockchain, but that's where we're starting here. And so first off, these financial service offices, they don't desire to be blockchain operators. They typically have small, lean IT shops. They just don't want that burden. Plus, there's a greater sense of decentralization, clearly, on a public blockchain. The users are, the investors would be more comfortable if the people running the blockchain are, independent from either the builders or, the key players in the overall transaction. Also, there's a future opportunity for network effects. Making it an open network. So for now, for the near term, value transfer takes place off-chain using legacy financial rails. But perhaps in the future, these securities can be tokenized or subdivided in different ways, combined with other securities, all the benefits of decentralized fintech certainly are applicable here. I think there would also be benefits for public data, particularly municipal government projects, to be able to have the details of the way that the money is flowing, the expenses for public works. It would certainly be great to have transparent on the blockchain as well. For the architecture, there's really three key components here. There's some others we'll go through, but there's the blockchain, of course, IPFS network. Right now I'm using a public IPFS network, but I'm not sure all the trade-offs of a public versus private IPFS network. And the Chappie nodes, of course, which are either publishers or subscribers. So for the flow of data, currently the publishers are just fabricating fake data, but in the future, in the real world, it would be generated either by the users who would be using the front end, or there would be some integration with legacy systems, financial applications, and so forth. So the publisher uses a channel name, and anyone who has access to that channel is in possession of a private key, and they're able to decrypt all the messages on that channel. Here's an example transaction. These are double entry accounting transactions, so a little different from blockchain transactions in that it's more like legacy accounting. These things have been around forever. I think like the 15th century is when this general ledger chart of accounts style accounting was first used. And essentially the accounts have to offset an amount so that each transaction is the sum of it is equal to 0. And so with one account in here, account 1, this number would be positive in that direction, and then it would be negative in the other direction so that it would offset to 0. And in this example, or in this test harness, I just assume that it's just 2 accounts, but it can be many. So then that gets encrypted. It gets encrypted with a symmetric key, and then the symmetric key is encrypted with the Johnson asymmetric key. And then that object gets put on IPFS. We get back the CID, and then take the CID and we publish it to the blockchain. On the subscriber side, we're using diffuse GraphQL to streaming GraphQL to receive the data, and then it gets decrypted and saved into a file. So here I have a parameter for a ledger file, and that is it's just putting the data, the transactions there. Now it does require it's a different format, so the subscriber is also transforming this JSON object into this format that Ledger Manager needs. And that gets saved to disk, and the balance sheet and the income statement, they just get refreshed. And so we'll see that. And so just a little bit of the layout that we'll see on the screen in just a second. The publisher I'm using Google Cloud Platform, and it's in Mumbai. I'm using the Kylin network, as I mentioned. IPFS is on the East Coast of the US on AWS. And then the subscriber and Ledger Manager is running on Google in Salt Lake City. All right, so I'll start with the Ledger Manager. So here we are going to watch for crystal.dat and run the income statement report. And here we'll do Ledger Manager. We'll watch for crystal.dat and the report of BSE. Here on the middle subscriber, I've shown these are the channels. So there's just a public and a private key file there. So we're gonna run the subscribe action on the Crystal channel and the ledger file of crystal.dat. And here we'll publish to Crystal, obviously, and then there's an option for just a readable memo that just is one of the action parameters on the blockchain. All right, so let's stop it there. So you see it fabricated this data, the equity builder expenses, 6.1 million, encrypted it, saved it on IPFS, called the blockchain action, and the subscriber here, Defuse, picked it up. It takes the JSON object and reformats it to the format that Ledger likes. And these guys over here were listening to the file and refreshed the refreshed the income statement and refreshed the balance sheet. So we can start it back up. The colors on the right will change just to show that that there was an update. It was kind of hard to see without that update, without the color change. So again, there's no concurrency here, and see, look, that transaction failed. So this happens, and I don't have any fault tolerance yet to to replay that transaction. Yeah, like I was saying, no concurrency, which there should be, and it's once every 2 seconds. Oh, here, this is a really nice feature of Defuse. It has picked up that the transaction was valid, but then it was reverted, and we have that message. So there's a micro fork there that it didn't keep up with. And you see these are just, continue to refresh every time there's a new transaction. It's not just an append-only transaction log here. It's actually refreshing the financial reports. And here's where I believe I should be able to use different nodes. Again, either replay things or maybe use a number of different nodes. All right, well, I'll just pause the video here. All right, I'm gonna change a couple things here. I've reset the ledger file so there's no transactions in there. And I'm changing, I have a variable for the publish interval. And I changed it in my other file. This is just a sample because I had private data in there, but I changed the publish interval in the regular file to 200 milliseconds. So it's going to be much faster, and I have no idea what will happen. I guess since there's no concurrency, it doesn't change much. So there could be multiple subscribers and multiple publishers to the same channel. They are, it just is a matter of who has access to that key. All right, I'll just, it's probably enough. So in terms of the permissions, it can mask or hide the message contents, obviously. It can hide the message publisher by using generic keys. It can also mask the subscriber and the number of subscribers, and just any combination of the above. So it can achieve, obliviousness or your global ghosted. The only two things that it can't hide are the network, obviously, and then the timestamp of the message cannot be counterfeit. And a little bit of how that works, I think it's mostly obvious, but there's in this example just one network, but there could be many networks, EOSIO networks, and this is all using a single contract called Messenger Bus and single action on that smart contract. And so you could publish to the so first you publish to this network, you can publish to the smart contract, you could publish to a channel within a smart contract, and then you could actually, because each node on the network has their own device key, RSA key, you can publish to specific entities. So that would be used for when a new channel is created. We would send the key file to all of the nodes that we were inviting to that channel using their device key. The big next step that we're going to be supporting is support for documents. Tons of these transactions, these financial transactions have PDFs, Excel files, images, scans, all sorts of files that need to be added. Instrumentation, dynamic key distribution. That's what I mentioned. And right now the ledger manager is sitting on the same node as the subscriber, but I'm going to work on making sure that's distributed. All right, thank you.